Today, I'll give you an executive summary, the business problem we're facing, the methods we use for analysis. I'll talk about the SWOT, which stands for Strengths, Weaknesses, Opportunities, and Threats Analysis that we conducted. I will address the question, what cloud computing is for those who aren't familiar with it. We will cover the service models, assumptions and constraints we use for migration planning. I'll give a high-level total cost of ownership analysis. Then we'll get into hidden costs, opportunities for cost performance optimizations. I'll account for hidden costs and provide everyone with a revised TCO. I'll present the environmental impact and conclusion. So let's get started. The executive summary. We'll achieve a 64% infrastructure cost reduction that equates to $7.8 million in a 3-year period. We can save an additional 20% on server hardware costs by optimizing our application architectures while improving overall resiliency and uptime. We can get to market 50% faster simply by being able to provision on demand. Cloud services are friendlier to the overall environment. It improves our opportunities to derive greater business value through the use of state-of-the-art services such as data analytics. The business problem we're facing. We had a 26% increase in infrastructure-related costs over an 18-month period, but the linear growth of infrastructure was only 20%, so our costs are outpacing our growth needs. We had a 62% developer satisfaction survey rate on our annual Voice of the Employee. 86% of developers cited frustrations and their inability to get work done. All of them cited provisioning as being a major roadblock to getting new feature releases out the door. We had 2 major unplanned release delays as a result of change dependencies which weren't accounted for, where critical patch releases caused additional downstream dependencies. And finally, we have no clear pathway for leveraging data analytics and machine learning platforms. Let's jump right into our SWOT analysis because I think it's important to know where we are before we discuss where we need to be. Our strengths. We offer a feature-rich voting application. We're #1 in customer support in our market niche. We're consistently rated amongst the top 3 in voting application software. We retained our innovative developer staff who want to speed up new features. We have an executive leadership team that's committed to making our product better, and one of our core values is to support green initiatives. Our weaknesses, we have high IT costs, and they're rising disproportionately with our rate of needs. We have long lead times to provision infrastructure. We have inflexible architectures that are a result of standardization. For example, we only have 1 flavor of server, and it isn't optimized on a per workload basis, such as CPU optimized or memory optimized or storage optimized. We have 200 servers that are all the same standard size because of limited platform offerings. That means everyone gets the same sized portion without considering how hungry they are, and it leads to waste. Opportunities. We can achieve faster provisioning, leading to faster development. We can remove infrastructure provisioning and concentrate on creating an agile culture that emphasizes creating business value. For example, we should be concentrating on providing voter authentication and weighted voting and mobile voting and SMS voting. The list goes on. We can optimize our IT environments for performance and costs. Threats. Our competitors aren't standing still, and it's very likely they're already using public cloud. We'll have privacy and security concerns as we continue to extend our market overseas. And we will face challenges optimizing our applications to run in the cloud. Our goal here must be to capitalize on our strengths and opportunities while minimizing our weaknesses and threats. So what is cloud exactly? Well, according to NIST, cloud computing has 5 major characteristics. The first one is on-demand self-service. That means cloud customers can quickly provision things like service and storage on an as-needed basis without the typical delays that we experience stacking our own data centers with equipment, then provisioning storage, network, and compute resources to our infrastructure and application teams. The second is broad network access, which is the ability to access resources from any location using a diverse range of devices like PCs and laptops and tablets and mobile phones. Increasing accessibility of cloud services may sound scary, but in implementation, there are many ways to restrict users to only access what they need. Resource pooling is the third major characteristic. Cloud providers maintain vast pools of hardware resources that they then serve up to many different customers. So CSPs carve up those resources and assign them dynamically according to demand. For data governance reasons, during implementation, we have the ability to restrict resources to one or more geographic regions or locations, addressing privacy concerns and also disaster recovery planning and resiliency. The fourth major characteristic is rapid elasticity. Cloud service offerings have capabilities that automatically adjust to scale, so we can meet temporary spikes in demand and shrink back down when the resources are no longer needed. Whether we need 20 servers or whether we need 2,000 servers, it will give us the ability to quickly spin up and wind back down in accordance with our business needs. And lastly, cloud offerings are measured services, much like water, the water meter outside your house. You pay for what you use, but unlike the spigot that delivers water, cloud delivers a vast array of services in different sizes and flavors, which I'll get to later. As with everything, we need to understand the hidden costs not captured in the TCO so that we can revise our estimates to give us something more realistic. I use the analogy of an iceberg because we are good with what we can see on top, but it's what resides below that could sink the ship. And it's especially true because we need to be able to control our cash flows. There are a lot of hidden costs that have to be allocated for up front, and we need everyone to understand what they are and how we plan to deal with them. So included here are costs associated with cloud governance and training and new hires and professional services, security operations, DevOps and integrations, application optimization, and I promised to get to earlier, continuous integration, continuous deployment efforts, or CI/CD pipeline, and monitoring and reporting. Okay, let's talk about optimization. Simply moving our existing infrastructure into the cloud alone is not going to give us the cost savings that we're hoping to achieve. We need a plan for what our applications could be and not what they are today. One of the essential characteristics of cloud that I mentioned earlier is elasticity, the ability to grow and shrink on demand where we only get charged for what we use. Right now, even with virtualization, our servers are running at an average CPU utilization rate under 20%. So we're paying dearly for excess capacity. One of our major tasks will be to achieve 10% optimization gains per year starting in 2021. In order to do that, we need to be able to use auto scaling so we're not running 200 servers 24/7. The opportunities don't end there either. Other optimizations include the flexibility afforded by different service types and family types. EC2 alone, we can use CPU optimized or memory optimized or storage optimized or high performance compute that leverages GPUs and hardware accelerators. For storage, we have flexibility in choosing S3 standard or the intelligent tiering or S3 infrequent access or S3 Glacier for data archiving. These are just a few offerings that can help create better experiences while reducing costs. There are, of course, other areas that I don't have time to cover, like managed services and serverless computing, that we could use to automate infrastructure tasks to reduce overhead. Now on to our revised TCO. We see a cost save of $7.9 million. That represents a 3-year cost save after accounting for the additional $650,000 of IT labor costs. And to keep myself honest, I realized that I did not account for project management services, which would downward revise these estimates by an additional $300,000. To $7.6 million. My apologies for that, and I'll be updating the slides. But it also assumes technology optimization savings of $330,000 based on a 10% optimization effort for 2 years. So some of you may be wondering how cloud computing is a greener alternative. Well, it turns out there's a body of science-based work that shows Monmouth data centers as being more energy efficient. With demands for electricity continuing to rise, large investments have been made to curtail energy consumption. In fact, large modern data centers have outpaced every other industry in energy efficiencies. That's something that's pretty astounding. Demand growth for new energy is being counterbalanced in part by new energy efficiency trends. As global citizens, we have the opportunity to lend our efforts to reduce our carbon footprint and at the same time save money.